Okay, in connection. Uh, I hope they don't take the lights now. But yeah, I think we are good. What is the time? All right. So, am I live? Let's stream. Yes, I am live, and great. So, okay. Yeah. I started with so I solved some stack questions yesterday. I learned about stack, the different operations we can do on stacks, and yeah, some basic stuff about stacks. So beginner level stacks question. Um, Nothing much. Uh, yeah, think. Okay. All right. So what I'll do next is to try something else. Not something else. So learn and solve problems. So I already searched, stack data structure problems here, and I'll get some problems to solve from randomly anywhere. So we have top 50 stack problems. I'll also choose from most, yeah, lead code first, and then I'll also use hacker rank to ask questions. All right, we have okay. So this is sorted from easy to medium to hard. Oh, so this postfix question was infix question was hard. It was medium. Nice. That wasn't bad at all. Um, you know what? Let's look at okay valid parentheses. I've done this already. Um, what was that? Actually solved this question before. Uh, I think I should solve it again. I think I should solve it again in order for me to get a really, a good hang of it. I don't remember how I solved it, but yeah, can try it out. And also, I need to sort the difficulty here. So maximum nesting depth of the parentheses. I'll take that as well. So those are two questions from um, leads code. Yeah, I'll do this one. Um, Remove outermost parentheses. Okay, I'll just leave this here um, on this side. So if there's time, I can continue with those. Also, parenthesis checker. Are these like similar questions? Yeah, this is same as the other one. So let me not take that. Reverse a string using stack. This could be a good question. So I'll keep this here. I might even start with this one. So yeah. And which other one? Maximum element balance brackets. I think this is the parenthesis problem. Yeah, so this stack, just stack. I'll choose largest rectangle or um, game of two stacks. Yeah, I'll just choose game of two stacks. So here are the questions. I'll just move this to this side here. Okay, so whatever is on the left is none. I'll clear my canvas now, so I'll just do this. Yeah, so my canvas is cleared, and yeah, so let's start with the first one. I'll just put this here. Okay, um is this a question, or anyways, there is no, you know, prompt here to read about the question, but I can still sorry, I can still understand what they're asking from this output here, right? So this is going to be an easy question, almost very too easy. Solve problem. What's this? Does this take you to like a canvas where you can solve the problem? Yes. Okay, I'll do it here, but I want to use Python, so okay, yeah. What's going on? You know, this is like a very weird environment for me. Um, oh my God, I've taken light. They have taken the light. Has it been 8 hours since? Um, Light's gone, but I can still, carry on with the stream, and we live in a pretty harsh condition. So I'll need to go and get light, and because I can't see on my other screens now. So can't see on my other screens. Oh, this is crazy. Okay. Um, Light is back. This is going to be tough, honestly, and I can't even imagine how difficult this is. Um, Okay, so um you are given a string s. The task is to reverse the string using stack. um I think I've been doing this all this while. So your task is you don't need to read input or print anything. Your task is to complete the function reverse, which takes the string. Hold on. Okay, which takes the string s as an input parameter and returns the reverse of the string. Um, Expected time complexity is O of n, and expected spin. Well, if we're going to use stacks, then we're definitely going to create an array, right? And how is it going to be space of, and space complexity of n? Oh my god. Please don't end my stream. Please don't end my stream. I don't know. The light is just really bad today. I think I can connect to another network. Okay, this network is better now. Oh, right. Let's see how we can solve this question. So the question is just to reverse a string, right? So the last character will be the first one, and so on. This is quite very simple, straightforward. So we can loop through each character in the string, and we add, so since we are reversing, we start from the last character, right? And we loop, and in a decreasing order in terms of indexes, in a decreasing order. So we'll start with the last item, and then we'll add it to the stack. So the last item will be the first to be added on the stack, and so on until we get to the first letter here, and then we append that to the stack as well. We'll put it at the top of the stack. So it was the last item to be added to the stack, but then it is the first item that appears on top of the stack. So yeah, so how do we do that? Well, we are reversing a string s. So I'll create a new stack. So here's what I'll do. Let me set a timer and see how this goes. So my time starts from now, and then I'll do this, right? I'll say, you know, I'll call this a reverse stack, right? And set this to be equal to an empty array. Sorry, this should be an empty array, and what I'll do this is to get loop through each item in the string. So I'll say for I in range. So I want to start from the last item in the string. So range, so we are going to start from the last item is the length of the string. So length of the string s minus 1, right? But then we want to go all the way to the first one, which is 0. So we'll do minus 1, but then we want to reduce it by 1. The step is 1 backwards, right? So we need to add -1 to it. So that is it, and we'll say, so reverse stack is going to dot append, right? We want to append the last item, I mean the character at I. So I'll say s at I, right? And you don't need to read input or print anything. Your task is to complete the reverse function, which takes a string and returns the reverse of the string. So Once we are done, we want to return the reverse of the string. So we'll normally do return reverse, right? Reverse reverse stack, but we don't want to do it this way. We want to return it as a string. So here's what we are going to do. We are going to say reverse and then just, you know, string like this dot join every item in the stack. Okay, so let's see, how do we run this code? Submitted, reset code, where is it? Okay, I accepted, so submit, run. Let's see what we have here. It says error, runtime error. Your output has a long time error. Okay, join reverse stack is not defined. Reverse, oh, reverse. Let me just copy the name so that I know I'm not making a mistake. Reverse. Right, so let's see, compile and run. Yeah, so geeks for Greeks. So yeah, this has been reversed. So we use the stack to solve this. So yeah, I've solved question 1 on my list, so the easiest one, and let's continue with others. So we have a valid parenthesis problem. I'll just create here this time around. Guess what I'm going to do? I'll just close this here, open my folders. I'll say stacks here. I'll create a new file. I'll call this what question there? So reverse the string, right? Reverse string. So I'm reversing a string here, and then I'll just copy this question here so that I have the reference to the question. So here's what I'm going to do. I'll just copy everything here like this. So I want this here, and then I'll just come here, put it here like this. Oh my god, I only copied one part of the question. That could not be possible. So copy. Yeah, so we have reverse string here, and I would need to, add a reference to the question. So maybe include the link here. Where's the question again? So I'll copy here. I can, I can even do it this way. So instead of doing that, just copy here. This is better, and then I'll put it here like this. So yeah, so we have reference to the question. What's here? Arguments, name should be lowercase variable. Yeah, I mean, this is what I was given the question. So right, oh, I did stop the question. I think I saw this under 2 minutes. I saw the question when I was running code, so it was under 2 minutes. Yeah. Okay, so that's it. Let's close this. Valid parenthesis. So I'm just going to copy this and put valid parenthesis here. Sorry, stacks, new question, new Python file, and valid parenthesis. So valid dash parenthesis. How do you spell parenthesis? Parenthesis, yeah. This is so yeah, let's read the valid parenthesis problem and try to solve that as well. So given a string containing, I've actually solved this question before, but I don't remember how I did it. So I'm going to attempt it again and understand it properly. So given a string as containing just the characters, an opening parenthesis, closing parenthesis, curly brackets, closing curly brackets, opening bracket, and closing brackets. Determine if the input string is valid, right? So an input string is valid if one open bracket must be closed by the same type of brackets. Um, Open bracket must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. Okay, so something like this is true because this is an opening bracket and the corresponding closing bracket is this. So this will be true. Um, Input S. So we have open, close, right? Open, close, open, close, open, close. Alright, but here this is false. Okay, is there any other constraints, any hints? Well, the topic is going to be stack and string, so yeah, we are going to be using stack. Um, so giving a string containing these characters, right? Right. Well, we know our strings will always start with um an an open bracket, right? Or yeah, an open bracket of a certain type. It could be normal bracket or parenthesis in this case, curly bracket, and this square bracket here. So here's what I'm going to do, right? How do we know? First of all, um, okay, there's no other constraint. So S is the length, so it could be anything here, consists of parentheses only. So the string will not have any other characters except for this parenthesis. Okay. Yeah. All right. Mm, Let me see the test cases here. Okay, they're still using the same thing. Where's my stylus? Um, Let me close. Okay, my stream is going on. Content live and go live. So just close these ones here. Right. Okay. So um, sorry. We are here. Valid parenthesis. So basically, we are going to use a stack to solve this question. And if we're using the stack, right? Let's say, okay, let me just put this beside the question so that I don't go too far. Um, in the first case, we have this parenthesis like this, right? So a string has to start from an opening parenthesis. Oh God. A string has to, start from an opening bracket or parenthesis and must have a corresponding closing parenthesis. Right? In this case, this will be valid, right? This is valid. Uh, so this also means that the question says every every closed bracket has a corresponding open bracket of the same type, and open bracket must be closed in the correct order open brackets must be closed in the same type of brackets, closed by the same type of bracket, sorry. In this must be in the correct order and must have a corresponding open bracket of the same type. So, well, in what case this uh, a string is not a valid parenthesis, right? Well, when we have something like this, you know, this is not valid as it's indicated here. This is not valid. We although we have um a corresponding closing bracket, but it's not of the same type, right? So this is not valid. And which one wouldn't be valid as well? So a closing parenthesis, right? If you start a string like this, then this is not valid because there's no way you can continue this string and close this one here. So this too won't be valid. So when a string starts with a closing parenthesis, then we know it is not um, a valid string, right, or a valid parenthesis. So we just return false in this case. Also, um, another case will be, so every closing parenthesis, right? Every opening parenthesis must have a corresponding brackets. Let me just use brackets and stop saying parentheses. So every close bracket has a corresponding open bracket, yes, which is of the same type. So which is what I said here. So we can't start a string with an opening bracket. This is wrong. Um, Open brackets must be closed in the correct order. Mm, so let's say open bracket must be closed in the same order, right? Which means we can have something like this, something like this. Okay. Um. So it also means if we have like open, open, open like this must close this must close that, right? Both of these are the same. This must close this, and this must also have a corresponding closing bracket. I think uh those are like the most important cases that we need to have. So when we have I am an opening bracket, when you have an opening bracket, we can add it to a stack, right? So we add it to a stack like this. So every time we see an open bracket, even when we see an open bracket like this, we can add it to the stack. Just be on the look for a corresponding closing bracket. So in this case, when we find uh, you know a square bracket like this, then we know that the topmost item in our stack has to be the corresponding opening bracket. So we then we'll pop this off our stack, we'll remove it from the stack, and then the next item um, will be this open parenthesis here. Then we need the next item we will need to find in the string has to be a closing one. If we find another opening here like this, if we find another opening here like this, we can as well add it to the stack, right? So I think we can do that. We can as well add it to the stack. I'll just erase that and bring back the C here. We can add it to the stack, right? We have the curly, as long as we find a corresponding closing bracket at the end of the day, this will be a valid parenthesis string, right? Because this this will match this will match that, and this will match the first item in our stack. So yeah, I think that solves the question. And let's go into the implementation. But because I had already solved this question, I'll write a brute force code here to kind of um, to get the I don't want to waste more time on this because I already seen the solution. This is already valid. So we add opening brackets to a stack, and when we find and a closing bracket that matches the bracket we added to the stack, then we just pop it from the stack. We remove it as it is the topmost item in the stack. So let's say in the case of this string, for instance, right, so here I'll just use this one like this. I'll say, well, since we are starting with a closing parenthesis, I mean opening brackets, sorry, we need to add it to our stack. I always represent stack like this because I want it to be, although this is an array, I just want it to be like this, so I see where what is or the topmost item. So I'll just add this to the stack, and then the next item in the course of our iteration will be this, right? Will be a closing bracket. So this closing bracket has to have a corresponding opening bracket, which is the item that we look for in our stack, right? So our stack is here. Then we look into the stack. What is the item that is in this stack here? We can see that it is the corresponding opening bracket. But how do we know that, right? How do we know which item this corresponds to? So I've been using something all this while, which is a map. So we can use a map to create a corresponding opening bracket for all our closing brackets. So we can do this will correspond to an opening bracket like this. A curly bracket will, I mean a closing curly bracket will correspond to a closing bracket like this, and we have this one here which will correspond to this. Yeah, okay. So regardless of how many opening brackets we have, they must have a corresponding closing bracket. So in the case where we have a string like this, let me just erase this part here. I'll just go through like this quickly. All right, so in the case where we have something like this, um so we have an opening bracket, another opening bracket, something like this, and then another opening bracket again. The next item in the, because every time we see an opening bracket, we add it to the stack, right? So our stack will look something like this. It will look like this. It will look like the this this this. Sorry, we have the square one. So square here like this, and then this, right? But when we begin to look at the match, right? So the next item, if we're closing this strings, right, the next item would be a closing parenthesis. The other one will be something like this, so that when we look for the corresponding value of this, right, in our map, it will be this value here, and our topmost item has to in the stack has to match whatever the corresponding uh, opening parenthesis of this closing parenthesis is. So here we can see we have this closing parenthesis here, I mean opening parenthesis here, and then we have opening parenthesis. So we remove this from our stack, right? The next one is this closing one here. So this closing one, what is the corresponding value? It is this, right? So we look in our stack, what is the topmost item in the stack here? It is this one, so we remove this from the stack. The topmost item will be this opening square brackets here. So our string has, the next item in the string has to be has to be this one here, like this, here, this square one. And let me just try and spoil this. I'll just add another square again, and then another curly brace. So when we are looking at this, the next item here is this, right? So what's the corresponding value for this? The corresponding value is this one here. So what is, I mean, the corresponding opening brackets is this one. What is the topmost item in the stack now? The topmost item is this, so we will remove this from our stack. They've taken the light again. Oh god, there's no way. Can't make this up. I think I should just go and turn on the inverter. Yeah, Alpha. Okay, so here we go again. Hopefully they don't cut off my lights this time around. Let me see if my internet is working so that I can, you know, connect to it. Oh god. This is not good. This is not good at all. Anyways, so where was I? This is crazy. Okay, so we look for so when we are at this point, when we are iterating to the string, right, and we are at this point, we look for the topmost item in the stack, right? Before we even look, right, we find the corresponding value of this one here in the map. So the corresponding value will be this one here, and then we'll find out if the topmost item in the stack is equal to this, right? So of obviously the top of the stack will be this one here, so yes, it corresponds. So we remove it from the stack, and then you know we go through again. So we are at this point now, right? Now what is the corresponding value for this bracket here? The corresponding opening bracket will be this, right? Will be this bracket here. So what is the value at the top of the stack? The value at the top of the stack will be this close opening parenthesis here, and the opening parenthesis is not the same as the opening square brackets here. So this string won't be a valid parenthesis string, right? Or group of parentheses. Yeah, so that's like a brute force uh, code for this problem, and yeah, I think that's it. But in the case where we get to the end of the string and we find every valid, or corresponding opening brackets, then we can return true or return false in like this case here where we don't the top item the topmost item in the stack is not uh it's not the same as the opening pair of this one here, so we return false. But in the case where it is, we continue until we reach the end of the string and then return true. Okay, I'm back now. Honestly, this is disappointing, but I didn't expect anything better. It's totally normal. This part. Well. Okay, so since I've solved this before, let's see what I did exactly. So I have a dictionary for every closing parenthesis, right? And then I'm adding to the top of the stack. I'm comparing. So I have a map for every closing parenthesis against the opening one, right? And if I have when I see a closing parenthesis, right? When I see a closing parenthesis and the stack is not empty, it means there's an item in the stack. I will still need to compare, right? If the topmost item in the stack is the same as the corresponding value or the corresponding opening bracket for the closing bracket we just encountered in the string. If it is the same, then we remove it from the stack. Otherwise, we return false. Or in the case where we just see an opening bracket, we just want to add it to the stack. So return true if not stack, right? So if there's still an item in the stack, right, and we are at the end of our string, I mean, if there's no item in the stack and we are at the end of our loop, then we want to return true, right? Which means it's a valid parenthesis. Otherwise, we want to return false because there's no way there should be one item left in the stack, and you know, so it's just something like this, right? This is a very typical case. Let's say I had um I had something like this, a closing, and then something like this, and then another one like this, right? And then the string stops here. Although I've added 3 items in my stack, right? 1, 2, and then 3, right? I've added these 3 items in the stack, and then I pop this off for their corresponding closing brackets. This still remains in the stack, right? But it doesn't have a closing pair, so which means it is not a valid parenthesis. So there must not be any item left in the stack, otherwise we return false. Okay, so the next question will be this one here. Maximum nesting depth of parentheses. I have not solved this one before, so yeah. Maximum nesting depth. Okay, this is quite verbose, but let's see. A string is a valid parenthesis string, denoted VPS, valid parenthesis string, if it meets one of the following: if it is an empty string, or a single character not equal to this or that. So a closing opening bracket, closing bracket. It can be written as AB, A concatenated with B, okay, where A and B are VPSs, right? Or it can be written as A within a parenthesis where A is a VPS. We similarly define nesting depth, right? So we have a depth here of VPS as follows. So depth is equal to 0, depth C, where C is a string with a single character not equal to this and that. Max depth, depth A plus B is equal to max depth A, depth B, where A and B are VPSs. Depth of this plus A plus this is equal to 1 plus depth A. Okay, where A is a VPS. For example, we have an empty string, this, that, this, that. They are VPSs with nesting depth 0, 1, okay, and 2. And these are not VPSs. Okay. Interesting. Let me read this again so I understand it very well. Max, the depth of C is equal to 0, but the maximum here, max of depth A plus B is equal to maximum. So we have a string here, an opening string plus A plus a closing string equal to 1 plus depth A, where A is a VPS. For example, we have this, that, and here. These are, so let's see, 1, 2 matches this. Opening, opening, closing. Well, it doesn't matter. Closing, closing, but closing here. Okay, with depth 0. So whenever we see, okay, so this will be 0, 0, and then 1. But then we see 1 here. Then we see 1. That is 1, 2, and then how about this? Is this not 3? Okay, so it has to be, in sequence, right? So we have 0, 1, and 2. This here is just like covering these two here. Mm, string must not be this. These are not VPSs. But here is a VPS with depth 0, 1, and 2. Interesting. So let's look at this example here. We have, 1 plus here 0, 1, and then we go within this. Here we see a value here. This is 2. But hold on. This would correspond to this. So we have plus 1. Wait. This is not really about the operations, it's about the nesting, right? So an empty string or a single character not equal to this and that, right, is a valid parenthesis string. Valid parenthesis string. Valid parenthesis string. So the parenthesis has to be valid first, right? It's nothing to do with the string at this point. To my own understanding, I'm not sure, but the string is, because why is this here? Why is this 0, right? I mean, we are looking for the depth of the parenthesis. Why is this 0? Because there is no parenthesis here, right? And why is this 1? This is 1 because it's just one single parenthesis. There's no parenthesis within it. So the depth here will be 1 all the way. Is that correct? And here we can see we have 1 here, right? But then we have 2 other parentheses within this. So this will the maximum will be 1, between 1 and then 2, right? So 2 will be maximum here. We can define the nesting depth. So we first of all need to know what a valid parenthesis string is. First of all, it is an empty string, right? The valid parenthesis string, right? It's an empty string or a string with any other character aside from this. Yeah. Okay. It can be written as AB, A concatenated with B, where A and B are VPSs. So valid parenthesis string, right? Good. Now it can be written as A within a parenthesis, where A is also a valid parenthesis string. We can similarly define the nesting depth, right? So we need to also define the nesting depth. What is the nesting depth? How many nesting depth is just how many parentheses we have within a parenthesis, right? How far we can go nesting this parentheses with the others. Yeah. Because here the nesting depth is 0 because we don't have any parenthesis here. This is 0. The nesting step we see here, right? So let's say depth here It's just a function that is being called. This will also be 0 because C is not within any parenthesis. Okay. Well, the depth of A plus B, they say A plus B is just a concatenation, so AB here. So it will be depth of A, depth of B, where A and B are VPS, so they are not strings that contain, this. There could be any other thing, a number or anything at all. But the depth of a string like this, so where we have this plus A plus, something like this. When we have something like this, the depth will be 1 because we only have one valid parenthesis here. Okay. And I think it just be 1 plus depth A. Really, how many strings are we passing here? So if we concatenated this would look, it's a single string like this, right? And then we are passing it here. So the reason why this is 0 is because there's no valid parenthesis here. And then the reason why this is 1 because within the matching, within the pairs that match each other, there is no other one, so this will be 1. And when we start from here, we already have 1, right? But then we have another closing parenthesis here which has 2 within it, so the maximum between these two will be 2 because we have 2 here. So we have 1 outside is 1, and then inside is also 1, right? So this will be 2 within the string. And here this is not valid, so this is not valid. Every opening bracket must have a corresponding closing bracket like we did here. So I think so without actually looking at this, right, what will be the value here? Okay, it's I've already seen it. This is 3, but why is it 3, right? The reason why it's 3 is because here we have, an opening and closing parenthesis. That will be 1, right? So when we see an opening and closing parenthesis, we have to record it as 1 and calculate it against other pairs. So here we see an opening, another opening again, but then we need to also see another closing, right? This here, right? This here is 1, and outside of it is also 1. So this is 2, right? This is 2, but then we have 1. So currently the maximum here will be 2, right? 2 against 1. And then when we go further, we see other opening. Then this will match this one here, this will match this one here, and this will also match this one here. So how many pairs do we have here? We have 1, 2, and 3 pairs. So the maximum inside this string here, the maximum depth will be 3, right? Because we have 3 pairs of parentheses matching each other. Right, I think it's quite clear now. And so S consists of digits. Let's read the constraints. S consists of digits from 0 all the way to 9, and characters like plus, minus, and everything, all of these, right? It is guaranteed that parenthesis expression S is a VPS. Parenthesis expression S. So S is the string, so it is guaranteed that it is a VPS. So what we need to do now is to find out the depth, right? So we don't even need to check if it is a valid parenthesis or not, but you just want to return how deep it is, right? So here, this is not a depth yet. When the string starts like this is not depth. I don't think so. You can just cover this like this. Wait, it is a depth. It starts from here, right? So we have here and then here. This is one, right? This is one, and then we have this and that. So here, this is another one. This is another one here. So the depth here is one. So this depth here will be, wait, let me see this again. Yeah, okay. So why is this is 3? Because if you look at this, 1 and then 2, right? This is 2. This would have been 1. Sorry. Um okay. So why is this you know digit 8 is inside of 3 nested parentheses. We have 1, 2, oh, and 3 all the way here. This is already valid at this point. So this is closing this, so we ignore that. But when we go here and then here, this was easier, right? So we saw 1, right? And then we have 1, 1, 1, but this will make it 1. It will complete it to 1, and then this will be 2, but then 3 will be 1, 2, and then 3 here. This will be 3. This, why is this 3 first of all? Well, you need to so this is the a digit, right? Hmm. It is true that this is inside, but what are we comparing it against? If we find an opening parenthesis, we need to look to the right and see how many more is left. This will be 1, right? 1, and then we want to, because we want to compare how deep a string is within the parenthesis, or a VPS, varied parenthesis string. We want to compare how deep it is, right? Um, to know how deep a string is, we need to see how many pairs surround it, right? So even when we are starting from this, right? This is 1, right? And then this is 1, and then we have another match. This is closing this already. So we know already that this, we've seen a valid pair, but how many more are there to its right? Right. If we can do that, I think so. We can look to the right and see how many more is there. Right. It's just one. So when we see another closing, then we know that this is already closed, and this has a depth of just one. Right. This is just one deep. This string here is has a depth of 1 for now. In reality, it has a depth of 2, right? Because all the way to this side here is 2. But we just want to know how many more. If there is like 2 more, if there were like 2 more to the right, and then we find a match for those 2, then it would have made sense, right? So let's see. Um, so when we find a closing one, that means we are looking at a new maximum, right? So I'll just say close, opening, right? That will be, so right now we'll have like 3 openings to the right. So this is not part, but like 1, 2, and then 3 here. So this will be 3 openings, and then if we just look if we can match all the 3, right? We'll just have 1, 2, and then 3. So it has matched the right openings, and yeah, I think that would be nice. So I'll copy this and see if I can find a proper solution for this. Here you go. I'll do it this way. So paste this here. Right, we have this like this, and then I'll just use this other one here. I'll paste this here, so as like my second, give this one a different color. Great. um okay, so here's what we are going to do. Let me take my pen here and then look at this one here. So first of all, we're obviously going to use a stack, and we'll stack uh every opening string here. So let me start with this one here. So I'll have a C here. Obviously we'll have like a corresponding map here. I'll just create the map quickly. So our map will look something like this. This will correspond to this. This will correspond to something like this, and then this will correspond to something like this. So that will be our map, and then we'll stack every opening parenthesis or every opening bracket into the stack. So we have an opening one, and then we have another opening one here. So this is another opening, but every time we see a closing, right, that will be our first depth. So here we find a closing. Of course, this closing matches the topmost item in the stack. So I'll just put this as our first depth. So our max depth for now is 1, right? Until we find another closing, we can't really continue counting for the max. So here we just go into the phase of looking for matching pairs. So here, this here matches this, so we remove this from our stack, and our current maximum depth will be 1, right? Our current maximum depth will be 1, and the next time we loop, we want to find a match for this last item here, right? This is another match we are looking for. If we don't find a match for it, then this will be our first match, our first depth that we will ever find for one particular pair of VPS, right? Valid parenthesis string. So the next item will be this, right? This one here. This is a closing parenthesis, right? We were expecting to get a another closing for this, so we need to stack on top of our stack. This time around, we know that we are trying to get a new depth, right? So a new depth will begin from here. So this is a closing parenthesis, and then we find another closing parenthesis again. So this will be two closing parentheses so far, and then now we see an opening parenthesis. So what do we do? Well, we'll still find out if the topmost item in the stack matches this. Of course, it's going to match. So yeah, so our maximum count starts from now. So we begin to remove. So we look here, right? This is 1. So we remove this. Our when we compare to the previous maximum, it's the same. So we don't even bother returning a maximum yet. So the next one will be another closing. So we remove this from the stack. You can see I'm removing from top to bottom because we need to pop the first item from the stack, and then every last item becomes every following item becomes the first item in the stack after removing the previous first item. So here, this is our uh, current item at the top of the stack when we are at this point here. But then we find another one here, which is another closing. Of course, there's another closing parenthesis in the stack. Then we can remove this from the stack as well, right? So now we've reached our stack is now empty. The stack is empty now. So the stack is empty, and we don't have any other parenthesis in the string, so we don't even bother to find another valid pair, right? So here's what we are going to do. So each time we were removing, right, we were counting how many times we were removing. So this will be 1, 2, and 3, and we compare it with our previous maximum, right? We compare it to our previous maximum. Our previous maximum was 1, so we don't we compare it with 3. So 3 and 1, the bigger number is obviously 3. So 3 is our depth, depth in this string here. So we have a string, a VPS, right, valid parenthesis string, that is 3 times nested in some brackets or parentheses. So we can do the same thing here, right? So I'll do the same thing there. Here's what I'll do. I'll just remove these quickly. Sorry, I'm removing my strings. I need to bring them back, so I'll just do this like this. So here will correspond to this, and this will correspond to that. Okay, now I'll put my stack here again. I usually like doing it this way, but I can still do an array. It doesn't matter. But yeah, let's just visualize things properly. So first parenthesis, right? I'll just go this way. I'll just go with this color. Let me use this one. So we find an opening parenthesis, right? An opening parenthesis. We put this in our stack, and then we find a closing, right? We find a closing. Sorry. When we find a closing, we want to remove the corresponding opening from the stack, right? So we look here in our string. We just want to make sure that it is valid, although the question says it will always be valid, but we still need to keep that edge case under control, right? So let's say here we have a closing parenthesis, and then the corresponding we have a closing parenthesis. The corresponding opening parenthesis will be this value here in our stack. So we remove this from our stack, right? So we are here. We were here before, right? So this is 0, and this will be 1, right? So once we remove from this stack, once we pop, right, the maximum at this point will be, you know, will be 1. So we already removed 1. The depth here, the maximum depth at first is 1, because we don't have any other item to remove from the stack, so we just return 1. Now the next time we see another opening, right? When we see another opening after a pair, right? After a closing, we just know that we want to start a new count for a new maximum. So we add this closing to this place here. That is 1. And then the next one will be this another opening. Sorry, why do I call it closing? It is an opening. So I'll just put this here, and I'll use a different color so that we'll know that this is no longer here. We just think it's not. So this will be the topmost item in the stack and the first item in the stack, which corresponds to this value. And then we'll find another one here. We add this to the stack again, but this time around we found a closing bracket. So we know the count for a current maximum is done, so we just want to confirm that. So once we find a closing pair, a closing bracket, right, and the topmost value on the stack is actually valid, right, which is this one here, we begin to, when we pop, we begin the count, right? So let's pop the first item. The first item was the last item added to the stack, so we'll do this. We'll remove this, right, and then the count here is 1, right? Now our previous, let me just call this prev, the count here is 1, right? This is not the maximum yet because it's not bigger than this, so let's continue our count. So we remove this again. Our count now will be 2 because we are at this point here, so our count now is 2, right? Now we know we are done with this VPS here, this 2, right, valid parenthesis string. So we know we are done, and the current maximum we found here was 2, right? So we compare 2 to the previous maximum depth we found before, and 2 is bigger than 1, so the current maximum now will be 1. So will be 2, sorry, max is 2. But we are still not done with the string, right? So we have another closing pair here, closing bracket, so we add it to the stack again. We see another one, this is 1. We see another one again, we also add it to the stack here. So this is 3. And then the next one we find is this, right? It's a closing pair. So what do we do in the case of a closing pair? We begin to pop from the stack. So this obviously matches this. So we've popped 1. We see another closing pair, we pop it again, that is 2. And when we find another one again, that is 3, we pop it. So how many items have we popped from the stack so far? It is 3. So the value here, the maximum here in this situation will be 3. We compare it with the previous. I'll just put P max for previous maximum. Yes, 3 is bigger than 2, so we return 3 as our maximum since we are at the end of the string. Yeah, so 3 will be the max here, and that is 3. So that is all. That's all we need to do to find the previous maximum. I mean the maximum depth, right? The maximum nesting depth of the parenthesis. Yeah, so I think that's all. I think that's all. So we need to write the code for it, and yeah. So where do we do that? I want to do it in Lit code. Let me see if I know to be able to code faster. I need to do it here. So I'll say maximum nesting depth, right? So I'll create a I did this already. Valid parenthesis, yeah. Let me just put it here so I can provide the code here. So this is the first one I did for valid parenthesis. And this question and the valid parenthesis question are similar, right? They are quite close to each other, except this time around you are counting how many times you are popping a pair, a valid pair from the stack. So yeah, that's cool. That is cool. So I'll take this here. Just put this one right. This is okay. So just remove this, and then I'll create a new file in the stacks. So here I have Python, and I have maximum nesting, right? What does it say? Maximum nesting depth. So I'll say max nesting depth. Sorry, max nesting depth. Yeah. So I'll just copy the starter for this code here, and then yeah. So here is it. What's going on? This not a problem. So first of all, we want to create a stack, right? So I'll say uh, I'll call it bracket stack, right? I'll call it bracket stack. Let me just say bracket stack like this, and this is going to be equal to an empty, sorry, array. Right now, what do we do? Well, when we find an item um, that is a parenthesis, right, or an opening bracket, we want to add it to a stack. But how do we know if the correct item in the string is a valid parenthesis, or it is not just it is not just any other character, right, aside from a bracket, a curly bracket, or a square bracket? So well, we still need to create a map, right, to check inside the map, right? So we need to create a map. um we need to create a map of uh how many map do we need to have? Because the first map will at hold on, let me just increase my time here. um I'll give myself another 30 minutes. So okay, so we need to know, like we need to have a way of determining that okay, this string is actually um is a is a parenthesis, right? It's like it's not just any other character aside from an opening parenthesis or closing, I mean an opening parenthesis, an opening square, or curly brackets. So how do we do that? Well, I'll just create I'll just create this. I'll call this openings, right, and set it to be equal to, sorry, and set it to be equal to just only opening brackets, because we are looping through the strings and we need to get uh, valid, not just any value, but like values that are either this, this, or that. Okay, because we might have numbers in the string as well. This is not a valid VPS, so I mean valid parenthesis string. So which is why we keep uh, our valid VPSs here, our invalid VPSs, sorry. Then I'll create a map for the a map for the I'll just call this closing map, closing Abby, yeah, closing map like this, closing map, and set it to equal to a dictionary. So I'll create it like this, and the corresponding pair will be this, and then I'll have another one like this. So here, like this, and the corresponding pair will be this, and then I'll have another one like this, which one do we, okay, here the square one, and the corresponding pair will be this. Oh, sorry, it's going to be the other way around here, and there you go. So here is our map. First of all, we need to check if the correct string, right, is this here. If it's in this place, we know that we started with an opening string, so we'll add it to the bracket stack, right? We always want to add the bracket stacks here. So, and we need our max. We'll just call this max depth, right? Oh, the name is already there. I was just say max count. Let me just put it like this. At first it's going to be 0 because any empty string will basically be 0, right? So, and any other value that is not, a string will be 0. And the max count is what we want to return, right? So I'll just say return max count for now. So already we've met the requirement for our function. The next thing to do is to just count how deep is a VPS in the bracket strings. So we'll first of all start by iterating over each character in the string. So for I in a range of length of the string, so what is the length of the string? So I'll say what is the string? The string is S. Okay, so what do we want to do? Well, in this case we want to first of all check if it is an opening parenthesis, right? If it's not an opening parenthesis, then we must know that there's already an item in the stack, right? So if the string has I, you know what? How about, okay, this still works. I mean, I'm not complaining. So if if we can just use the for I in S, right? It will directly get each item in the string, but you know, well, we can still use the range. Doesn't matter, really. Doesn't matter. So here's what I'm going to do. Uh, okay, somebody says I don't really understand this question. So it says uh, here. Okay, show that we have 3 here. Okay, so I have a question. I don't know how I'm going to show this, but the question says I should, let me just quickly drag this here. So here's a question I have from the chat. It says show this so that we can know that there is 3. Okay, let me copy this and do it and see if we truly have 3. I'm just seeing that now. Let me go ahead and prove that. So I'll just come here, and where is my board? Okay, so I'll erase everything I had here and paste what I have from here. Okay, so right here we go. Where's my, so we're going to use, let me use this color here. I'll put my stack here, right? So there is my stack, and we'll start from here, right? So I'll have my map. Obviously this will correspond to that, this will correspond to this, and then this will correspond to this. Okay, so the first parenthesis we have here is this. Although this is not a valid equation, but we don't mind if there is any plus or minus here, so it doesn't really matter. So let's start with this. So we start from this part here, right? I'm sure this is everything, right? Okay, so here there is one, so we add this to the stack. I'll just use a different color, right? Let me use this color here. I'll add this to the stack. Or let me use this. So this is our first item. Sorry, what's that? Okay, so this is our first item in the stack. We add it to this stack here because it's an opening parenthesis. So the next one we see here is a closing parenthesis. So once we find a closing parenthesis, we need to validate if the correct item at the top of the stack is actually the corresponding value for that closing parenthesis. So here our correct maximum at this point will be 1, so we have 1 here for now. So we have 1 here, and we remove this from the stack, right? So we are at this point here now. So this will be the first item we see, this will be the second, and then we start seeing a closing, right? So this will close this, so this will be 1, this will close this, so this will be 2, right? You can see I start from the top to the bottom, always start from the top to the bottom and not the other way around, because this will be the last item in the stack or the topmost item in the stack. So you need to cancel this first before this. So the correct maximum at this point is 2, right? This is 2, so this will replace that. Then we go again, we have 1, and then we have another 1 here. So these two will cross each other. So when we see another one, we add it to the stack. We see a valid one, we close the stack, right? And then we see another, opening brackets here. There is no item in this stack to, do any other operation. So let me erase this. I'll just erase everything here. So we go again. So here, this is our, we are at this point, right? Let me use a different color. So we are at this point, so we add this to the stack, we add this to the stack, and then we see a closing one here. So we already know that we want to validate it with whatever we have here. So here we can't continue adding to the stack because this is a closing pair. So we remove this from the stack, so our current count will be 1. But the next item we see now here is an opening parenthesis. So this already here, the maximum here is just 1, so we leave it, right? We leave it. So we add whatever we have next in the stack. So we add another closing parenthesis. Let me just erase this quickly. We add another opening parenthesis here, right? And then we see another one here, we add it again, and then we see a closing parenthesis, right? We see this closing parenthesis. So what do we do when we see closings? We want to pop the items from the stack. So here's what we are going to do. So when we see a closing, we remove this. So we start counting, which is 1. We see another closing again. Yes, this is 2. And then we see another closing again. This is 3, right? So which means we have, which is 3. So which means we have 3 as our current maximum, as the previous maximum used to be 2, but now 3 is now our current maximum, and we return 3 hours maximum. Yeah, so that is the question Ram Prasad asked. So yeah, that's how we find the maximum. All right, so I hope that was clear, and so I'll go ahead and implement this. But yeah, that's really it, right? So we always want to add an item to the stack when it is, an opening bracket or an opening parenthesis. So we are not using brackets here, we are just using parentheses here. So which means, right, which means we don't even need oh, I see, we don't even need this, right? We don't need this 2 here. We only want this, we only want that. That's all we need. Oh, okay. Yeah, we don't need that. We don't need openings and closings, right? We just need one closing. So I'll just call this an opening, because we're only using parentheses, we are not using any other brackets, right? Let me just validate, let me just confirm that. So you can see the test cases here do not have any. So yeah, so we are not using any other one aside that. um so 36, I've done 1 hour test. So here too, we don't need this, we don't need this at all, we don't need this. I'll just call this closing. It's just going to be a single string, right? This is an opening, this is a this is a closing, right? So if this item here is equal to a closing, right? If it's equal to the closing one, right, we want to append it to the bracket stack. So bracket stack dot append, sorry, we want to append s at I, right? We want to append, you know, when it's a closing stack, we want to append at s at I. And then if it's not a closing tag, else, so I'll just say else if sorry, this is elif if s at I is equal to sorry, this has to be a closing, an opening, sorry, opening here, and then this is a closing here, right? So if the correct item is a closing, then we want to start, you know, if it's a closing and there is item in the bracket stack, the bracket stack is now empty, right? Sorry, bracket stack is not empty, then we want to start popping, you know, removing from the stack. So here's how we're going to do that. So I'm going to start with this. I will start first of all, yeah, we will never add a closing parenthesis to the stack, so there's no need to even find out if the top item in the stack is this. So we want to remove the topmost item from the stack. So here's what we're going to do. We want to be removing as much as we can, right? We can't just do this, right? Bracket stack dot pop, sorry, pop, right? If we're popping like this, yeah, this works. I'll just create here like a I can create a maximum here. So here, well, I don't want the maximum value to be changing all the time. I mean, I want it to be changing, but if I set a value here, then it will retain that value. Well, when we pop for the first time, we want to start counting. So we want to start from 0 and then so on. So first of all, when we pop the first item, we know that it is 1. So we pop again, we look at the string and we see another item which is a closing bracket, and the stack is not empty. We want to pop again, so we want to do that over and over again. So every time we pop, we want to increase the count, right? And that count has to change for the next time we see another okay, so here's what we're going to do. Anytime I append a new item in the array, right, well, I want to reset the max count to 0. So max count should be equal to 0. And then when I pop an item, I want to increase max count by 1. max count plus equal 1, right? So every time I increase, I increase it by 1, but when I add an item, I want to, which it means I'm just, starting a new count again. So mhm. Well, and when I do that, I just always want to say max count here, right? Should be equal to uh the maximum, sorry, the maximum between, yeah. So I need, this is wrong. If I had a tracker here, I'll just say tracker is equal to, you know what, I don't even need to define any variable here. But if I define a variable here, I set this to be equal to 0, it will always change every time. So what do I do? Max count here should be equal to 0 when we add a new item to the stack and we want to begin tracking, right? Max count to be 0. When we pop, we increase max count by 1. Max count plus equal 1, right? We want to increase max count plus equal 1. And then at the end of the day, when we finish and we add an item to the stack, at the end of the day, the max count value here is not going to, we need to reset it to 0 when we add an item to the stack. So this will increase the max if there is no new item added to the stack. So the value of the max at the end of the day, yeah, so, well, so else, da 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 da. So first iteration, yeah, this is doing it already. Why am I confusing myself? So here we have max count, bracket append, set it to 0, increment it, and then we want to return the max at the end of the day. So when we loop, what's the current max? You know what? Um, I think if I had like, let's change this to a tracker, right? I'll just set this to a current max. I'll say this is current max, right? Oh, sorry. Current max, replace all. Um, current max, and then I'll just say max count is equal to 0 again, and then every time I do this, I say current max and I increase. For each iteration, I want to have a value, right? Because at the end of the day, we want to reset this to 0 whenever we add an item to the stack. So here's what I'm going to do. I'll just say max count, right, is equal to the maximum, the maximum between um, the current max and the other max count here. So this would be our maximum for each iteration. Because when we set this to 0, right, current mass, so let's say we have like 2, right, so this increased by 2, and the next time this will be 2, but each time we want the mass count to be of a certain value in the iteration. Yeah, I think we can return mass count now, right? I think I'm doing something wrong, but I'm not sure what it is, because I want to, reset current mass every time I add an item to the string, increase it when I pop an item from the stack, right? When I add an item to the stack, I want to reset it to 0. But this will also run for every iteration. Is that okay to do this? Is it okay? Well, the maximum value will always be the maximum between this and that. So whenever this is 1, right, and we go and we don't add any item, it is 2, then 2 will be compared to this one here. 2 will be the maximum. Yeah, this is good. This is good. So let me run this again and see the results. So I'm just going to come here, right, and put it like this. Okay, and just let's run this and see. Okay, I think something, yeah, it works. It has been accepted. Yay. So let me submit this and see what it is. Oh, wrong answer. Wow, this is interesting. Okay, so the output is 2 here, while the output is 3. Wait, is this what I've been asked? Hold on. I mean, it's similar, but yeah. So how is this returning 2, right? Why am I returning 2 and it's 3? Let's see. So here we have a an opening parenthesis. So we add this to the stack. We add this to the stack as well. That's 2. We have another one here, which is 3. Yes, it is 3. Right? It is 3 already. When I pop this off the stack, remove this from the stack. Oh, I see what's happening. I reset it to 0 because here, yeah, the depth here is 3. It is 3 because we have this 1, 2, and then the entire thing is 3. But there was one item left in the stack. Okay, I think I need to add an edge. If there's an item left in the stack before we stack another one on top, right? We need to be sure, we need to make sure that the one we are stacking on top is now our current maximum. I mean, when we reach the end, right, of this one, it has to go all the way, and the value has to be more than whatever was there before. Otherwise, we need to increase this other one here. Oh, that makes so much sense now. Oh, there's no question in the chat. Oh, I think that is the only. So before we reset to 0, right? Again, we still, because here's what's happening. We had this is some interesting case here. We have this and that, this and that. But if we are appending to the stack, right? we say when we are appending to stack, we need to make sure that the stack is first of all empty, because it could be the opening parenthesis for like a series of VPS where, so we have this, we have that, right? Yes, I think first of all, before we set to zero, right? We set to zero, okay? If the bracket so does not have any item, if no item is in the bracket stack here, if there is no item in the bracket stack, then we need, now we can set it to zero. Else if there is, right, if there is, then then we can still find the current. Okay, so if there's no item in the stack, we set it to zero. Else what do we do? What do we do if there is an item in the stack? Well, we can still continue. If there's an item in the stack, if there's like one closing parenthesis left, wait, um, wait. If this is an opening, if it's an opening, and there is an item in the stack, I mean, we want to append when we see an opening, so there is no need to check if there was a previous value. But when we append, right, we want to count. Um, we want to count the current maximum. No, we want to set the maximum to zero. But before we set it to zero, there must not be any item in the stack, right? But what if there is? What do we do in that case? Well, in that case, in that case, hmm. This is an interesting question. This is an interesting case, because if there is, here I'm saying, hold on, it's a closing bracket and there's already an openings in the stack, then we want to count how many openings there are. Okay, well, if there is, um do we keep the value of the mass count and say, let me look at this again. We want to add But if there is one left, right, before we add on top, because you know, if there's one left before we add on top, you see this maximum here. Let's imagine this was our maximum. So from here and then here, this is 2, this is 1, but then we have another one where all of these are in. But we're saying before that when we see a new this thing, right, we need to stack it on top. What if like there was other nested ones here? Um I think the best thing to do here is to keep one last one. So like if I had so if I had something like this, I could say um think about this properly. I'm coming. Sorry. So I had this value here. Okay. Okay. So here is the case where I have a string like this. So this is an opening, right? This is another opening. So that's 2. This is 3, right? This is 3 openings. But then we want to do 1, 2, but we have this here, so we don't continue it. So here's what I was saying before. So when we see a new this, we start counting for a new maximum, right? So here we do this again, 1 and then 2, right? This ends here. This is 1 nesting, right? This will end here. This ends here. This ends with this one here, right? But then, right, we had 2 here. We have 1 here. So if our maximum is bigger than our current one and there is another item at the end, right, we need to find out if that has a matching pair at the end, and then we just increment this by 1. But how do we do that in code? How do we know, the previous? Well, oh, oh, right. We know we found. Okay, yeah, I know what to do. So we need to first of all, if we can reset it to 0, it doesn't matter. But then when we increment, right, want to increment it this way. We also need to check if the current iteration is at the end of the string, right? If it's at the end of the string ah and the current max has a value that is less than our previous max, right? And we're already at the end of the string, and there is an item left in the stack, then we can just increment our max by 1, right? Yeah, I think I can say this. So I'll say if, sorry, I can do it this way. So that is a different, this is a different case. If I, um, you know, is equal to the length of the string s minus 1, right? If we're at the end of the string, and and there was one item left in the stack, and brackets there was still one item left in the stack, right? We just want to do mass count is equal to, wait, yeah, and the mass count, sorry, and the max count is superior to the current max, right? We just want to do mass count plus 1. Mass count is equal to mass count plus 1. Yeah, I can just do it this way. Yeah, I think this will work. This should work. Just come here, copy this, and go back to this place here. I just come here. Right. So let's run this first. Oh, wrong answer. Ha. Wow. Oh, you see, it is outputting 4. Well, you see, the well, this condition is just wrong. I can see it now, cause yes, reach the end of the stack, right? You know what? I can set here. I'll say if the bracket, if not bracket stack, if the bracket is empty. Wait, is this what I did before? Why would I do this? If no, I want to set this to 0 regardless of what happens. This can be 0. It doesn't matter. It doesn't matter. Yeah, this is accepted. So I saw what was causing the issue. Well, let's run this again. Let's submit it again and see if it works. It didn't. Same issue. Now I'm returning 2. It's expecting 3. If I'm the end of this, okay. So let's say, sorry. Let's say I'm at the end. I there was an item before I start resetting, right? Okay, so if there was an item in the stack, I'll just say, like, let me just say, let me just say ID is equal to last opening, right? There was an opening before I start resetting it to 0, so I'll just say this is equal to is last open, and I'll say this is equal to false, right? But if is an opening, right, If it's an opening, I could just check here and say if um if there was an item in the brackets, right? If bracket stack, sorry, if the bracket stack had a value, bracket stack had a value, right? And it could just be one, right? Bracket stack. Let me just say if the length of the brackets bracket stack, right? Len bracket stack. Wait, here. Mm. This won't work. You know what? This sucks. I've done 2 hours. I planned to do 1 hour, but yeah, I was able to solve 3 questions so far. But this is interesting though. You know this edge case here, where there was an item in the stack. If I don't find any items, right? If the last item in the stack and there is an item at the last end, there will always be, this will always work. But the point is, right, before I set reset to 0, I need to know, right, if there was already an item in the stack. Yes. If it's the opening stack, right, and there was no value, right, and there was no item in the stack, right, nah, this will not work because I need to add, wait, and there was no, and not stack, right, and not stack, sorry, and not stack like this, right, which means the stack was empty, right. I want to set the maximum to 0. Don't worry, don't worry, don't worry. I want to set this maximum to 0. So, but then else if, right, else if it's an opening, sorry, it is an opening. Let me just put something here like this. I'll just put this here. Right. Else if it is an opening, right. Wait, this is not going to work this way. What am I doing? Alright, let me see the editorial and see what they did. Yeah. Okay. Initialize variable answer to 0, which will store the maximum nesting nep. Okay. An empty stack st, right, which is what we did here. Iterate over characters, and if c is equal to, I, if it's equal to a prime, add it to stack. If pop one element or the stack, update ans maximum. Oh, whoa, and return. Oh God, why did? Oh, no way. This is what was killing me, right? This is the only thing that was killing me. So I could do this, right? The question says if we pop one item from the stack and update I answer. If it is this, remove this. So you see, this is no longer needed, right? We don't need the current this. So the maximum is just going to be the current length of the array, right? Of the stack versus the max that we find here. So uh so here this will be the size. Because every time we pop, right, it means there's, there's a certain amount of, okay, let me try this out and see if it works. um Current, the length of the stack, bracket stack, like this. uh Bracket stack. We don't need these. We don't need these anymore. Let me submit this and see if it works. If you actually work, the answer has been accepted. But yeah, this works. Let me just remove all of that. You know, sorry, I was submitting again. I removed. Oh, come on. I only needed to remove this. I didn't even need to create a variable here, right? We can just compare it directly. If this, so that we can take less time. If this, if we find an opening string, right, we want to add it. Else, if it is a closing string and the bracket is not empty, right? Okay, so we can remove those as well. Yeah, let me submit this again. We had 36 and 16 before, so let's see how many we get after removing those additional stuff. Yeah, it increased a bit. I don't know why it's supposed to go down, but lit code is just, I mean, I think I'm because I'm doing this but we still need to do this additional check, right? So here's what's happening. So when we find a closing parenthesis, we append it to the stack, right? The stack will have a certain size, right? We append it to the stack, and then we find, the current maximum at that point. Uh, Wait, we only need to find the maximum when we pop. Each time we pop, right? Because this will always calculate the maximum every time. So we only need to find the maximum every time we pop an item. Because it doesn't make sense to always calculate the maximum. Oh. Ah. So it got to the end of the stack and removed the item. So when the stack is empty, it will not update it here. So this is okay. Uh, I don't know why, but I still don't get maximum length of the bracket stack. Maximum length of the bracket stack. So let me come here to my drawing board. So this was the case where I was getting an error. Here we added this to the stack. I'll just create my stack here like this, right? We have closing, closing, and then another closing here, but we have a we have opening, three openings, and then one closing here. So here's what we're going to do. Well, if we find a pair, right? If we find a pair that matches this, which is at this point, this will be one depth, right? This is one depth, two depths. But here, we don't find anything here, right? This is two depths. We've gone two depths to get this operation here. But there's still one more left, right? So the maximum here, right, will be the length of this this stack here when there's just one item left in the stack. I'll just remove this. This is an interesting question. I like it. So it's making sense now. So when you find a pair, right? So here I'll just use the green color. So here this is one pair that we found here. This matches this. So we can do it like this and cross it off. Do it like this and cross it off. But each time we are, popping, right? This will represent one maximum depth, two maximum depths, right? Two maximum depths. But because we are adding more item uh, to this stack, right? We are not really, we are not really, we are not really sure that we are going to cross off every openings in the stack. So here's what I'm going to do. To explain this better, let me represent this again. So first we add an item, an opening to the stack. We add another opening again, and then when we are at this point, we add another opening again, right? So when we pop an item off the stack, right? When we find a pair, so this here is a closing that matches this, so we remove that. Now our maximum, right? Our maximum will be equal to the maximum between, you know, how many items have I popped yet so far. So let me just come here. So the maximum will be the current the current length of the stack, right? So after removing this, the length of the stack will become 2, right? The length of the stack will become 2. Every time we pop, right, we'll have to get that length each time. So first of all, the first time from the stack's length will reduce, right? The stack's length will reduce, and our maximum initially was 0, so 0, 2, right? So the current maximum, we already know that every time we add an item, right? I mean, we know every closing bracket will have a corresponding every opening bracket will have a corresponding opening bracket. So there's no case where you see like a closing bracket that does not have an opening, right? So let's just, you know, at this point we are sure that we are already going to get that. So which is why we need to use the length of the stack to calculate how many depth we are at this point. So this is every time we pop an item from the stack, right, we need to get the length of the stack against the maximum. So when we find the max here, right, in the max of these two, this will be our current maximum. The value here will be 2, right? So 2 is our current maximum. So the next time we calculate, right, we see another closing here, we cross that off. Max becomes max of, I'll just use m, or mx of the previous max, which is 2. And then what is the length of the stack now? The length of the stack is 1, right? So our max is still 2, right? So the next time we see an opening, right, we want to add an opening to our stack again, right? So this will be here 1. I'm coming. So here this we cross this 2 because we found 2 here, so it's remaining 1. So we add 1 more to it, right? We add 1 more to it. Then this is 2, and then wait, hold on. Am I missing something? This is 1, 2. This cross this cross that. Okay. So we have 1 again. We have another one that is closing it. This will cross this off and this will cross this off. This will be 2. So the value of the maximum here is 2. No, this is not correct. It should be 3. What am I doing? Hold on. Um, our max started from 0. So every time we pop an item from the stack, we need to find the length of the stack. So we have 1, 2, 3 here, right? Well, if we have 3, right? If we have 3, before we popped, right, the stack had a length of 3 already, right? I think this is the mistake I'm doing here. But how come why is this working? Because I needed to get the length of the stack first, right, before popping an item from it. Oh, okay. So I was already calculating it here, right? I'm not calculating the length when I pop. I calculate the length each time I add an item to. Okay, each time I add an item to the stack, I need to calculate the length. When I remove an item from the stack, I still need to calculate the length. So there's no fixed time for calculating the length. Okay, that makes sense now. So here, let's correct this. I will remove this from here. We only want to pop an item from the stack, so we don't need this, right? We need to calculate the length of the stack each time, because we'll always have a corresponding closing pair. So length of the stack, length of the bracket stack, yeah. And here we don't need this as well. We only append each time, so that is not necessary. These are not necessary as well. We could just find an opening string here. The opening string is like this, and then the closing string should be like this, you know. Yeah, we don't even need to calculate end this, right? I think this is why the time complexity was increasing for our our operation. But yeah, it's also necessary. But let me see, if I did this in LeetCode, right? What will happen when I remove this from here? What's going to happen? Will it tell me that I've reached? Will it throw an error? It accepted it, right? It accepted it, which is strange, right? But it's not also strange, because there will always be an item in the stack. You see, I mean, in terms of memory, it improved, but the time, I still feel like there's something wrong with this. Why is the time always increasing? Each time I run an operation, there must be something wrong with this, right? It doesn't make sense. It doesn't make sense. So let's run this again. It will change now. You see, the runtime has improved, and now the memory is 7.35. I will take runtime over memory, right? So we don't need this here. We don't need to check this at all. Let's see what other people are doing. I'll just go to the solution, Python, and see what is here. Beats 99%. Wow, interesting. For beats 99% in terms of what? Wow, runtime. Interesting. So yeah, output is equal to 0. This is our temporary maximum. So for C in S, if C is equal to this, increase the maximum, right? It's not even using a stack. It's not using it. It's just counting every time we have uh every time we So here's what it's doing. So if there's a parenthesis, increase the temporary count. But if there's a closing pair that, obviously will pop one of our stack, or will match, a previous parenthesis, then uh then if the output if the temporary value is superior to the output, right? At this point we've not calculated an output, right? But yeah, the temporary value has been increased at least by one when we start, seeing parentheses. So here, yeah, this makes sense, but it's not using a stack, so it's work. It works, right? So the output will be temporary value, and then when we see a closing parenthesis, you know when we see a closing parenthesis, we want to reduce the temporary value by one. We'll always reduce the temporary value by one, but the output, right, will always be the current temporary value. Okay, this makes sense, and yeah, it works. It works. It works. It works. Beats 100%. What is this? So here's what it's doing. P plus equals to 1 minus. What's this? Like some dangerous. So if this is true, this will return 1, right? If this is false, it will minus 1. So negative 1 plus 1. Uh, well, right. I think this works. I need to close now. I have some other things to do. Okay, it was a good session today.